Hello, I'm Evan Prince, and in this video I'm going to be explaining how a thermodynamics 2 equation we used in class, the Antoine vapor pressure equation, is applied in real engineering. And the example I'm going to be using is NVIDIA's cooling of their high-power GPUs. So in modern graphics cards like NVIDIA's RTX 4090, they can generate approximately 450 to 700 watts of heat so that the chip doesn't overheat. NVIDIA will use vapor chambers, which usually move the heat by boiling and condensing a small amount of liquid, usually water because of its high specific heat capacity, and this will be inside of a sealed copper plate, and they'll usually have to scale this up for data centers for potentially thousands of chips. To design these systems, engineers have to know a crucial thermodynamic value, at what temperature the coolant will boil inside the vapor chamber, and that boiling point comes directly from the Antoine equation that we used in class, which is ln of p sat is equal to a minus b over temperature plus c. And this equation relates to the saturation pressure of a liquid to its temperature. In other words, it predicts the boiling point at any internal pressure. NVIDIA takes advantage of this because we know that water boils at 100 degrees C, which is far too hot for their graphics cards, and they will melt. So they need to figure out how to lower the internal pressure of the vapor chamber, and using the Antoine equation, they can solve for the pressure where they want the boiling point of the water to be, which is around 60 to 70 degrees Celsius, and that will match the normal temperature range of when the GPU will die. Therefore, it will have sufficient cooling, and the way this works is once the coolant boils, the vapor rapidly carries heat to the cooler regions, condenses, and then it returns back to the GPU for it to cool again, heat up the liquid again. This phase change loop removes heat for far faster than conduction alone and allows NVIDIA's GPUs to maintain stable performance while processing massive amounts of data. So this just shows how the Antoine equation, which we use to calculate vapor pressures, which we used in class, can be used as a tool in industry, specifically NVIDIA's cooling of their GPUs. Thank you.